Two storms are making headlines this week, and almost every piece of coverage is treating them as two completely separate stories. One is a disorganized tropical disturbance drifting toward the Gulf Coast. The other is a rare, top-tier, severe weather outbreak threatening a corridor stretching from Texas to Iowa with major tornadoes, and possibly a devastating derecho. Different regions, different hazard types, different agencies tracking each one. But dig into the actual atmospheric setup behind both systems, and you find something almost nobody is talking about. These are not two unrelated storms that simply happen to develop during the same week. They are two different expressions of the exact same underlying atmospheric pattern, drawing on the exact same reservoir of energy at the exact same time. That distinction is easy to miss precisely because of how modern weather coverage is structured. A hurricane specialist covers tropical systems. Severe weather reporter covers tornado outbreaks. Each beat exists separately. Each agency issues its own separate advisories, and each story typically gets told as though it exists in its own self-contained bubble, disconnected from whatever else the broader atmosphere happens to be doing at the same time. That structure makes sense for the practical purposes of tracking and warning about each individual hazard, but it also means the genuine physical connection between two seemingly unrelated severe weather stories can go almost entirely unmentioned, even when that connection is exactly what explains why both stories are happening during the same specific week in the first place. Understanding that connection is not just a meteorological curiosity, it explains why this specific week has produced this specific combination of extreme weather and why forecasters are watching both systems with more than the usual level of concern. If understanding the real science connecting seemingly separate weather events, not just tracking each storm in isolation, is something you want to keep doing. Subscribing means you catch the next breakdown the moment new information comes in. Let's start by properly introducing each system on its own terms, because understanding what each one actually is makes the connection between them considerably easier to see. The severe weather outbreak is the more clearly defined and more confidently forecast of the two. According to AccuWeather senior meteorologist Courtney Travis, the atmospheric setup driving it combines three specific ingredients: unusually strong high-altitude winds, a surge of deep moisture streaming north out of the Gulf of Mexico, and sharp temperature contrasts colliding along the same frontal boundary. That combination led the Storm Prediction Center to issue a high-risk designation, the single most serious warning category on its 5-tier outlook scale, specifically covering a corridor running through Texas, Missouri, Illinois, and Iowa. High-risk days are issued only a handful of times across an entire year, reserved specifically for situations where forecasters have unusually high confidence that a major tornado outbreak or a long-lived hurricane-force wind event called a derecho is about to unfold. The Gulf disturbance tells a very different kind of story, one defined far more by uncertainty than by confidence. It began as a broad, disorganized area of low pressure near Florida's Big Bend region, the kind of system that lacks a clear, well-defined center of rotation from the start, making it notoriously difficult for forecasters to track with precision. Early guidance suggested it would either stay weak and disorganized or drift harmlessly north along the southeast coast. That forecast has since shifted as a ridge of high pressure reorganized the steering pattern around the disturbance and redirected it west toward Louisiana, with the highest uncertainty window arriving as the week transitions into the weekend. Unlike the severe weather outbreak, the National Hurricane Center's development reflecting genuine uncertainty about whether it ever organizes into a formally named storm at all. Here is where the actual connection between these two systems becomes clear, and it comes down to a single shared ingredient: deep, record-warm moisture streaming north out of the Gulf of Mexico. That phrase appears in the description of both systems for a reason. The severe weather outbreak's instability, the fuel that allows thunderstorms to explode into dangerous supercells capable of producing significant tornadoes, comes directly from Gulf moisture, surging northward and colliding with the strong upper-level winds and sharp temperature boundary already in place across the plains. The Gulf disturbance itself is sitting directly on top of the source of that same moisture, warm ocean water running measurably above its seasonal average across large stretches of the Gulf this year. Both systems are drawing on the exact same underlying atmospheric reservoir. They are simply channeling that shared fuel supply in two different directions, one feeding a slow-building tropical system over open water, the other feeding an explosive, severe convective outbreak hundreds of miles inland. Understanding why the same moisture source can simultaneously power two such different types of severe weather requires understanding what that moisture actually does once it enters the atmosphere. Warm, humid air is less dense than cooler, drier air, which means it wants to rise. As it rises, the water vapor within it cools and condenses into cloud droplets, releasing stored heat energy in the process, a phenomenon called latent heat release that provides much of the actual fuel driving explosive storm development. whether that storm is a tornado-producing supercell over Missouri or a slowly organizing tropical low over the Gulf. Latent heat release is worth understanding a little more precisely, since it is genuinely the engine behind nearly every form of severe weather this video is describing. Water absorbs an enormous amount of energy when it evaporates from a warm ocean or land surface, energy that gets stored invisibly within the water vapor itself rather than immediately warming the surrounding air. That stored energy only gets released once the vapor condenses back into liquid water high in the atmosphere, forming the towering cumulonimbus clouds associated with severe thunderstorms. And that release happens as genuine, usable heat, warming the surrounding air and causing it to rise even faster, reinforcing and intensifying the storm's updraft in a self-sustaining cycle. A moisture-rich environment, exactly what record-warm Gulf water is currently providing, supplies more of that stored energy for storms to tap into, which is precisely why both systems this week have access to an unusually large fuel supply, regardless of which specific type of severe weather that fuel ultimately gets converted into. The difference in what each system actually becomes depends heavily on what other ingredients that rising, moisture-laden air encounters once it starts ascending. Over the plains, that rising air runs directly into strong wind shear and a sharp temperature contrast, ingredients that organize the resulting thunderstorms into rotating supercells capable of producing tornadoes. Over the open Gulf, without that same land-based frontal boundary and wind shear pattern, the same rising, moisture-rich air instead has the chance to slowly organize into the kind of broad, rotating circulation that defines a developing tropical system. This divergence comes down almost entirely to wind shear, and specifically how much of it each environment actually contains. Over the plains this week, strong upper-level winds blowing at a different speed and direction than the winds closer to the surface are tilting developing thunderstorms, separating their rain-cooled downdraft from their warm, moist updraft, allowing individual storms to organize into long-lived rotating supercells rather than collapsing under their own rainfall the way an ordinary thunderstorm does within an hour. That same strong wind shear would be actively hostile to tropical development, since a tropical system specifically needs low wind shear to maintain a vertically stacked, symmetric structure as it slowly organizes. The Gulf disturbance is benefiting from sitting in a comparatively calmer wind environment, allowing it the chance to potentially organize precisely because it is not experiencing the same disruptive shear currently organizing supercells hundreds of miles to the north. The same moisture, arriving into two environments with dramatically different wind shear profiles, produces two entirely different outcomes as a direct result. This shared origin point also explains something that might otherwise seem like an unrelated coincidence: why this specific week, rather than some other ordinary week in August, produced both of these systems at once. Record or near-record warm water temperatures across the Gulf of Mexico this summer have provided an unusually large, unusually available reservoir of moisture and heat energy for the atmosphere to draw on, considerably more than a typical summer would offer. When that oversized reservoir gets tapped simultaneously by two different atmospheric setups, a favorable steering pattern allowing a tropical disturbance to organize over the water, and a favorable combination of wind shear and temperature contrast allowing severe convection to organize over land, both draws happen at once rather than one following the other, with some natural spacing in between. In a summer with more typical Gulf water temperatures, the same broad atmospheric pattern might have been able to fuel one serious system or the other, but perhaps not both simultaneously with this much intensity. It helps to understand roughly how much additional energy a few degrees of extra ocean warmth actually represents, since the difference sounds modest but carries genuinely outsized consequences. Water requires an enormous amount of energy to warm even slightly compared to air, which is precisely why the ocean can store and later release such large quantities of heat into the atmosphere above it. A Gulf running 1 or 2 degrees Fahrenheit above its seasonal average across a wide enough area represents a substantial increase in the total heat and moisture available for the atmosphere to draw upon, not a trivial rounding error. That extra available energy does not automatically guarantee more severe weather will occur. Plenty of summers with warm Gulf water still pass without producing a week this active, but it does raise the ceiling on how much severe weather the atmosphere is physically capable of producing if the right triggering ingredients happen to align. Exactly the scenario currently playing out across two different regions at once. It is worth being precise about what this connection does and does not actually mean, since drawing a link between two systems can easily be overstated into something more dramatic than the science actually supports. These are not the same storm, and one system is not directly causing or triggering the other in any meaningful physical sense. They are better understood as two separate consequences of the same underlying cause. An unusually moisture-rich, unusually energetic atmospheric environment currently sitting across the Gulf and the broader southern United States, capable of fueling multiple distinct types of severe weather simultaneously rather than being limited to producing just one at a time. That distinction matters because it shifts the useful question away from whether one storm might somehow merge with or worsen the other, which is not what is actually happening, and toward a more accurate question: what does it mean that the atmosphere currently has enough available energy to power two genuinely serious, independent severe weather events at the same time? The answer to that question carries real, practical weight for how seriously both systems deserve to be taken. An atmosphere capable of simultaneously fueling a high-risk tornado outbreak and a developing tropical system is, definitionally, carrying more available energy than a typical summer atmosphere usually does. That elevated energy state does not guarantee either system reaches its worst-case potential, plenty of severe weather. Setups with abundant available energy still fail to produce catastrophic outcomes due to other limiting factors. But it does mean the baseline conditions this week are genuinely more charged than an average August week. A detail that helps explain why forecasters are treating both systems with unusually serious language, even though they are, technically, separate and unrelated storms by any conventional definition. Meteorologists sometimes describe this kind of elevated baseline using the analogy of a fully loaded spring versus a partially compressed one. A fully loaded spring does not guarantee a dramatic release simply because it exists. Something still has to trigger that release at the right moment and in the right way. But a fully loaded spring is capable of a far more dramatic release than a partially compressed one, if and when that trigger actually arrives. This week's atmosphere, sitting on top of an unusually large reservoir of Gulf-sourced moisture and heat energy, represents exactly that fully loaded spring. And the two specific triggering mechanisms currently in play, the wind shear and temperature contrast organizing the plains outbreak, and the favorable steering pattern allowing the Gulf disturbance room to organize, are simply the two separate releases that happened to find that same abundant energy supply within days of each other. There is a broader pattern worth understanding here as well, because this is not the first time a single, unusually energetic, atmospheric setup has simultaneously produced multiple distinct types of severe weather across different parts of the country. Meteorologists who study these compound scenarios have noted that years with record warm Gulf water temperatures tend to correlate with an increased frequency of exactly this kind of multi-hazard week, since the same oversized moisture and energy reservoir that can fuel one severe weather type remains available to simultaneously fuel others, rather than being a finite resource that gets exhausted by a single storm system. This research connects directly to broader questions climate scientists have been asking about how a warming baseline ocean temperature might reshape severe weather patterns more generally, beyond simply making any single storm type more intense in isolation. If record warm Gulf water becomes a more consistent rather than occasional feature of future summers, the kind of compound, multi-hazard week currently unfolding across the country could shift from a genuinely unusual occurrence worth dedicating an entire video to, towards something considerably closer to a routine feature of an active summer season. That shift, if it continues, would carry real implications for how emergency management agencies plan and staff their operations, moving away from planning primarily around single, isolated disasters and toward building genuine, sustained capacity to handle multiple, simultaneous, severe weather events as the increasingly normal rather than exceptional part of the job. Understanding that broader pattern is part of why some meteorologists have specifically flagged record Gulf water temperatures as a factor worth monitoring closely for its role in producing exactly this kind of compound, multi-region severe weather week, beyond its more commonly discussed role in fueling any single storm's individual intensity. Given this shared underlying cause, here is what is actually worth understanding about each system's own specific risk profile, since the connection between them does not mean their individual threats should be treated identically. The severe weather outbreak carries genuinely high forecaster confidence, reflected directly in the rare, high-risk designation, meaning residents across the affected corridor from Texas through Iowa should treat this as a serious, well-established threat requiring real, immediate preparation, knowing your safe room, keeping multiple ways to receive warnings active, and understanding that a high-risk day can produce not just one dangerous storm, but multiple significant supercells tracking across the region over the course of a single day. The Gulf disturbance carries considerably more uncertainty, meaning residents along the potentially affected stretch of coastline should prepare seriously without assuming a worst-case outcome is guaranteed, focusing especially on flash flood risk given how much rainfall even a poorly organized system can produce when parked over exceptionally warm water. That flash flood emphasis deserves its own specific attention, since it is easy to focus entirely on wind speed and storm category when thinking about tropical systems, and overlook the hazard that actually causes the most damage and loss of life in many cases. A weak, disorganized system moving slowly across exceptionally warm water can draw up enormous quantities of moisture without ever developing the tight, well-organized wind. field associated with the name storm, instead wringing that moisture out as prolonged, intense rainfall over whatever stretch of coastline it happens to sit above longest. That is precisely the kind of outcome record-warm Gulf water makes more likely this week, regardless of whether the National Hurricane Center ever assigns this specific disturbance an official name. If you want to actually follow how this connection plays out in real time, watching both systems together rather than in isolation, here is what to track. Monitor Gulf water temperature anomaly maps, available through NOAA and other official sources, to understand just how much available energy the broader atmospheric environment is currently working with, since that number provides useful context for how seriously to take any severe weather developing across the broader Gulf and Southern Plains region this week. Follow both the National Hurricane Center's tropical outlook and the Storm Prediction Center's convective outlook together rather than checking only one, since both agencies are effectively describing different consequences of the same underlying atmospheric setup this week. And reading them side by side gives you a genuinely more complete picture than either one provides on its own. That combined approach applies well beyond just this specific week, too, and it is a habit worth building for the remainder of the season generally. Most people default to checking a single forecast source focused on whatever hazard feels most immediately relevant to their own location. A tropical outlook if they live near the coast, a severe weather outlook if they live further inland. Understanding that both types of severe weather can trace back to the same broader atmospheric conditions means checking both, even when only one seems directly relevant to your own region, can offer genuinely useful early warning about how much overall energy and moisture the atmosphere has available. Information that frequently ends up mattering for your own local forecast days before that connection becomes obvious through your own regional outlook alone. And understand that a summer producing this kind of simultaneous, multi-region, severe weather activity is worth paying closer attention to for the remainder of the season, since the same oversized Gulf moisture reservoir responsible for this week's compound event is not going away simply because this particular week's storms eventually resolve one way or another. What is unfolding across the country this week is not simply a coincidence of timing, two unrelated storms that happen to share a news cycle. It is a genuine demonstration of how much severe weather potential an unusually warm, unusually moisture-rich Gulf of Mexico can generate simultaneously, feeding both a rare, high-confidence tornado and derecho threat inland, and a slow-developing tropical system over the water at the exact same time from the exact same underlying source. Neither storm needed the other to become dangerous, but understanding that they share a common cause explains why this particular week produced this particular combination of extreme weather, rather than the more typical pattern of one serious system developing at a time. That is really the core lesson worth carrying away from this entire comparison. Weather coverage almost always presents individual storms as isolated stories, each with its own beginning, middle, and end, disconnected from whatever else might be happening across the rest of the country at the same time. The reality underneath that coverage is considerably more interconnected, a single, continuous atmosphere responding to a shared set of underlying conditions, capable of producing multiple, seemingly unrelated severe weather events from the exact same root cause. Recognizing that connection does not make either storm this week any less dangerous, but it does replace a sense of coincidental bad luck with a genuine physical explanation, exactly the kind of understanding that turns a confusing, overwhelming news week into something considerably easier to actually make sense of, both for the people directly in either storm's path and for everyone else simply trying to follow along from a safe distance. We will keep tracking both systems and the broader Gulf moisture pattern feeding them as new information comes in throughout the week. If you want those updates the moment they land, subscribing is the way to make sure you do not miss them. And if you live anywhere near either system, tell us in the comments what the actual conditions have felt like where you are. Because understanding how the same underlying atmospheric pattern is playing out differently across different parts of the country is exactly the kind of ground-level detail that helps everyone else make sense of. A genuinely unusual week, one shared cause producing two very different, very real experiences, depending entirely on which side of the country you happen to be watching it unfold from. Stay safe, and we will see you in the next one.